texture compression, why your game is crashing and how to fix it. Hello and welcome to episode number 11 of the Unity Performance Task Force podcast. I'm your host Ruben from TheGameDev.Guru, and as usual I'll kick things off with a question for you. Have you ever shipped a mobile game only to watch your installation rate tank because players see 2 gigabytes required and immediately nope out? Or maybe you've seen crash reports spike on older devices and you can't figure out why your memory budget just evaporated. Sounds familiar? If so, this episode is for you. Here's the truth most Unity developers learn the hard way. Texture compression is not optional. It's not a nice-to-have optimization you tackle after launch. Get it wrong, and you're looking at bloated APKs, crashes on mid-range hardware, terrible loading times, and players uninstalling your game to free up space. In my experience working with studios, especially in the casual and mobile space, textures are the worst offenders across every metric that matters. We're talking 70 to 90% of your package size. We're talking massive memory footprints in both RAM and VRAM, and we're talking brutal memory bandwidth costs that kill your frame rate, drain battery life, and turn devices into hand warmers. So let's fix that. Today I'm walking you through texture compression from first principles. By the end of this episode, you'll know which formats to use for PC, console, Android, and iOS. You'll understand the trade-offs between quality and size, and you'll have a repeatable testing workflow so you're never guessing again. Let's start with the stakes. If you've worked with images outside of game development, you might think PNG and JPEG are fine. They compress images, right? Problem solved. Not even close. PNG and JPEG use global compression. They look at your entire image, find patterns across the whole thing, and squeeze it down. That works great for sending photos over the internet. But GPUs don't work that way. When your GPU renders a frame, it doesn't need the entire texture. It needs a few pixels from one corner of an atlas or a specific region of a normal map. If you store textures as PNG, the GPU has to decompress the entire image just to grab those handful of pixels. That's a catastrophic waste of memory bandwidth. What you need instead is block-based compression. Think of it like this. Instead of compressing the whole image, you chop it into small blocks, say 4 pixels by 4 pixels, and compress each block independently. Now the GPU can decompress just the block it needs. Fast, efficient, minimal bandwidth. That's why formats like DXT, ETC, ASTC, and PVRTC exist. They're designed for random access, which is exactly how GPUs consume texture data. Alright, so which format should you use? Here's the short version, and I'll expand on each in a moment. For PC and console, your go-to formats are DXT1 or BC7 for textures without alpha. If you need transparency, use DXT5 or BC7. For Android, stick with ETC2 or ASTC depending on how modern your target devices are. For iOS, use PVRTC if you're supporting older hardware like iPhone 5, or ASTC for iPhone 6 and up. Now let's talk tiers. I think of texture compression in 3 quality tiers. Tier 1 is the best bang for the buck, excellent visual quality, solid compression ratio, and you should use it whenever your hardware supports it. That's ASTC and BC7. Tier 2 is your fallback, good enough quality, widely supported. That's ETC2 and DXT5. Tier 3 is the bottom of the barrel, ETC1 and PVRTC. You only use these when you have no other choice, because they introduce visible artifacts and feel like you're making a deal with the devil. The key thing to understand is that Tier 1 isn't just for high-end hardware. ASTC isn't locked behind expensive GPUs, it's locked behind device age. A $60 Android phone released in the last few years will support ASTC just fine, but a flagship phone from 2014 won't. So your job is to research your audience. Find out what percentage of your players are on hardware that supports the formats you want to use. Then make a decision: how much market share are you willing to lose? For Android, about 90% of devices support ETC2 and about 80% support ASTC. That's recent data, but always verify for your specific target market. Here's the trap. If you ship a texture compressed with ASTC to a device that doesn't support it, Unity doesn't just fail gracefully. It decompresses that texture into uncompressed RGBA32 format at runtime. That means two things. First, your loading times go through the roof because Unity has to do CPU-side decompression. Second, your memory usage explodes because now you're storing uncompressed textures in VRAM. Old device, low memory, long loads, crashes. You see the problem. The alternative is to build separate APKs for different hardware tiers, but that's a pipeline nightmare. I avoid it unless I have no other option. Let's get practical. How do you actually set texture compression in Unity? You do it per texture per platform in the texture import settings. Select your texture. In the inspector, scroll down to the platform overrides. Click the platform you care about, say Android, and tick the override box. Now you've got two key settings: format and compressor quality. Format is the compression algorithm: ASTC, ETC2, DXT5, whatever. This determines the size in memory and on disk. Compressor quality is how much time Unity spends trying to make that compressed texture look good. Fast compressor quality means quick iteration but lower visual fidelity. Best compressor quality means the image looks better, but it can take hours to compress large textures, especially with ASTC. Here's the critical part. Compressor quality does not change the file size. ASTC 4x4 at fast quality and ASTC 4x4 at best quality both take the same amount of memory. The difference is purely visual. So in your day-to-day workflow, use normal or fast compressor quality. Reserve best quality for your final build server, where you can afford the time cost. Now let's talk about channels. Most game textures fall into three categories: RGB textures, albedo maps, environment art, anything without transparency. Use DXT1, ETC2 RGB, or ASTC. RGBA textures, UI sprites, decals, anything with alpha. Use DXT5, ETC2 RGBA, or ASTC. Normal maps, they need special treatment. On PC, use BC5. It only supports 2 channels, but that's fine because you can reconstruct the third channel from the other 2 using simple math at runtime. BC5 gives you excellent quality for normals. On mobile, stick with ETC2 or ASTC depending on support. Then you've got edge cases, single channel textures like height maps, dual channel textures like velocity fields. There are specific formats for those, but they're less common. Let's dig into the formats themselves. ETC2 is the workhorse for older Android devices. It uses a 4x4 block size, which means one block holds 16 pixels. For RGB textures, that's 4 bits per pixel. For RGBA, it's 8 bits per pixel because you need to store the alpha channel. ETC2 is solid. It's widely supported, the quality is acceptable, and it compresses decently. ASTC is where things get interesting. Every ASTC block is 128 bits, but unlike ETC2, you control the block size. You can pack 16 pixels into that block, that's 4x4, same as ETC2, or you can pack 144 pixels into that same block if you go with 12x12. Smaller block size means better quality and larger memory footprint. Larger block size means worse quality but smaller footprint. That flexibility is huge. You can dial in the exact trade-off you need per texture. A hero character's face, ASTC 4x4. Background foliage, ASTC 8x8 or even 12x12. This is the exact workflow we use at TheGameDev.Guru when teams need fast wins on memory budgets without tanking visual quality. For PC and console, the story is simpler. DXT1 and DXT5 are ancient, but they work. DXT1 for RGB, DXT5 for RGBA. They're supported everywhere, even on hardware from 2005. If you're targeting DirectX 10 and up, you get BC4 and BC5. BC5 is my favorite for normal maps. Excellent quality, tight compression. If you're on DirectX 11 or newer, so PlayStation 4, Xbox One, anything modern, use BC7. It's on par with ASTC in terms of quality and compression ratio. The downside is that compression time is brutal. If you're compressing a 4K texture with BC7 at best quality, go get a coffee, maybe a meal. BC6H is for HDR textures. If you're doing physically based rendering with HDR light maps or reflection probes, that's your format. Alright, now you know the formats. How do you decide which one to actually use? First, test. Don't just eyeball it in the Unity editor. Test in context. Here's the method. Duplicate your texture, apply different compression settings to each copy, then swap them at runtime while you play the game. Bind it to a key press. Tap the key, the texture swaps, you see the difference in the actual game environment with real lighting and real camera distances. Do not zoom in to 400% in Photoshop and Pixel Peep. That's not how your players experience your game. If the texture is a book on a shelf that players never interact with, ASTC 8x8 is probably fine. If that same book is a quest item they pick up and read, you need ASTC 4x4 or better. Context matters more than objective metrics. Set a quality threshold. Decide as a team what level of artifact is acceptable. Then test every texture type against that threshold. UI sprites, environment albedos, character normals, particle atlases. For normal maps specifically, don't just compare the compressed normal map to the original in an image viewer. Apply both to a mesh, light it, and compare the shaded result. That's what players see. I built a simple web tool for visual comparison testing. You upload two textures, it shows them side by side, and you can toggle between different compression formats in real time. I'll make that available to Performance Task Force members. It's not perfect, but it's faster than re-importing textures in Unity over and over. Let me address a few common objections. What about crunch compression? Crunch is a second compression pass on top of your GPU format. It reduces package size, your APK or IPA gets smaller, but at runtime, Unity decompresses it back to the original GPU format. So your VRAM usage stays the same, your loading times increase, and your visual quality takes a hit. Use crunch if package size is your number one problem and you can stomach the quality loss. Otherwise, skip it. What about uncompressed textures? You almost never want uncompressed textures. The only time I see it is when a technical artist has a very specific use case and a very trained eye, and even then, the final user probably can't tell the difference. If you're in a fast-paced shooter and the player is sprinting through corridors, they're not stopping to admire the grain on a wooden barrel. Compress it. What if I need different settings for different devices? You can build separate APKs with different texture import settings per build. I've done it. You write a custom build step that iterates through all textures, checks a naming convention or a tag, and applies the right settings before building. Pair that with Unity's cache server so you're not recompressing textures from scratch every time. Otherwise, you're looking at hours or even days of build time depending on your asset count. Alright, let's bring this home with an action plan. Step 1. Research your target market. Find out what percentage of your players are on hardware that supports ASTC, ETC2, BC7, whatever formats you're considering. Step 2. Set baseline compression settings per platform. For Android, start with ETC2. For modern Android, try ASTC. For PC, start with DXT5 and BC5. For iOS, PVRTC if you must, ASTC if you can. Step 3. Build a test scene with representative textures, UI sprites, character models, environment art, particles. Apply your baseline settings and test on real devices, not in the editor, on the actual hardware your players use. Step 4. Identify textures where quality is critical. Hero characters, UI elements players interact with, anything viewed up close. Bump those to higher quality formats or smaller block sizes. Step 5. Identify textures where quality is not critical. Background details, distant LODs, things players never focus on. Compress those more aggressively. Step 6. Measure. Check your package size, your memory usage, your loading times. Compare before and after. If you save 200 megabytes on your APK and loading times go up by 2 seconds, that might be a bad trade depending on your game. Step 7. Establish theme guidelines. Document which formats you use for which texture types. Make it part of your asset import pipeline so new textures get the right settings automatically. And step 8. Revisit this every 6 months. Hardware support changes. Your target audience shifts. What worked a year ago might not be optimal today. Let's recap the key takeaways. First, texture compression is not optional. It directly impacts package size, memory usage, loading times, frame rate, and player retention. Get it right, or pay the price in crashes and uninstalls. Second, use block-based compression formats designed for GPUs. PNG and JPEG don't work. You need DXT, ETC, ASTC, PVRTC, or BC formats depending on your platform. Third, test in context. Don't pixel peep in Photoshop. Swap textures at runtime in your actual game and see what your players will see. Set a quality threshold and stick to it. If you want a second pair of eyes on your project, we do focused performance audits and training sprints at TheGameDev.Guru. We've seen these patterns across indies and AA studios, and the fix is usually smaller than people think. Sometimes it's just a matter of testing the right formats and setting up a sane import pipeline. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity Consulting is what you are after, book a free discovery call at http://consulting.thegamedev.guru. Till next time.